This is lesson 2.5. We're going to solve rational equations. So this is the favorite part. Once we have an equal sign, we get to reduce the denominator and eliminate it completely. That's the best part. But the first thing we have to do, though, is always convert to our common denominator. The first example we have here doesn't have any denominators. It's just to show us how are we going to solve for x. Well, this is just taking things across the equal sign. So typically we bring x to the left, but it really doesn't matter which side you bring them to. So I'm going to remove them from one side, so you're going to do the opposite function. So I'm going to subtract 3x there, subtract 3x on that side. Then I'm going to move that cube 2 to the right, and I'm going to subtract 2 to both sides. Okay? Then I'm going to add up everything that's left over on each side. So we're going to add up everything that's left over. That's going to give us our negative 2 zeros out over here, our 3x zeros out over there. So on the left, we're going to get a negative 1x equals negative 6. We never ever want to solve for a negative x. We always solve for positive x. So we have to always divide out the negative sign if there is one. All it does is switch the sign of your answer. So negative 1, x equals positive 6. Okay? Then they're going to ask you to check your solution to see if it's a true solution. So you would put it in the left side and then put it in the right side and see if the left side equals the right side. So I would have 2 times 6 plus 2. That's going to give me 14. That's my left side of my equation. My right side is 3 times 6 minus 4. Well, 18 minus 4 is 14. So the left side equals the right side when we figure it out. Okay, so that means the solution works. Okay? Now we're going to take one that's got only one fraction on the bottom. We like those kinds because they're the easier kind to deal with. If we've only got one fraction on the bottom, how do you remove any number or anything from the bottom? You do the opposite. You times it out. So that's all we would do. So, taking a quick look, just going to remove this over here. We can look at the guy in the middle here. I would times the 4 out to remove it from the bottom. But I must do it to every term. So that means I'm going to times the 3 by a 4, and I'm going to times that 7 by a 4. So if I multiply one thing by 4, I've got to multiply them all by 4. Okay? It just so happens it removes that 4 off the bottom, which we like. So now we're going to get x plus 12 equals 28. Okay? Now we've got to move our 12 to the right. So we're going to subtract 12. X equals 16. Okay? Most of this, you don't have to do a left side, right side check. We're okay with most of it. The last step always does say, do check your answers. All right, the next one, we have 2 different fractions. So if we have 2 different fractions, this is where we have to go common denominator. So, the third example. What is the common denominator between 3 and 4?
12.
12, good. So we're going to find what they have, what we would multiply to create a 12 on the top and the bottom. So the guy on the right was not a fraction. So you've got to create a fraction by putting them over 1. So we've got everything in fraction form now. We've got a 12 on our bottom. Now what we've got to do is figure out what do we multiply to each one of those, what is missing. So I would multiply by 4 on the bottom to create a 12. So I'd multiply by 4 on the top as well. So that's going to give me 4 m's on top. Okay? On the bottom, I have a 4. I'm going to multiply that guy by 3. And that's going to give me 9 m's. The 13 has a 1 on the bottom. So that means I'm going to multiply it by 12. So I'm going to multiply 13 by 12. So 13 times 12,
156.
156, perfect. Now, the minute you've got all your top numbers converted, okay, because you had to multiply them by something. Once you've got them converted, your your denominator is gone. It disappears. So now you can get rid of it. It's gone. And now we're straight up back to solving the equation. So we add our like terms on the left. So that's going to give me 13m's equals 156. And now you're going to divide out 13 to both sides. So what's 156 divided by 13?
12.
12, good. So m equals 12. Same as our common denominator in this case, ironically. Okay? It is a quick one. Yeah. All right, let's try a few more of these guys. Now we're going to actually throw some rationals in the bottom. Yep. Yep.
Couldn't you bring a 3 over first?
You could have, absolutely. Yeah, you could have minus 3 here, minus 3 here. That would have left less work. Absolutely. Yeah, you betcha. Okay, let's take a look at these guys. Now we've got monomial denominators again. So when we deal with monomials, they're stuck together. So we want to see what kinds of things are stuck together. So you look at the digits, and you see what is the largest digit that they can go into. Well, here we've got a 2 and a 4. What's the largest? 4. So I know 4 is going to be part of my common denominator. What else do I need?
X.
X, good. So if one of them has a variable, the other guy needs the variable. So this guy's going to be multiplied by, well, our common denominator, first of all, is going to be 4x. All right. I just make one big line. So on the left-hand side, what do I have to multiply by 2x to give me a 4x? 2. So you're going to multiply it to the top. That'll give you a 10. Then we're going to multiply it to the middle guy. What do I multiply by the 4 to give me a 4x?
X.
Just x. So we're going to multiply x to that guy. So he becomes a 3x. What do I multiply by the 9 to become a 4x? Nothing. He already has the 4x in the bottom, so you don't touch him at all. He stays the same. Now we do non-permissibles. So non-permissible, then we wipe the bottom off. What's our non-permissible? 0. So x cannot equal 0, and now we don't have a bottom anymore. So now we're going to take our 10 to the right-hand side. How do I move a positive 10? Subtract it. Good. I'm going to subtract 10 to both sides. That's going to give me 3x equals a negative 1. Okay, because you have to subtract 10 to both sides to move the 10 over. Okay? So we get 3x equals a negative 1. Now we're going to divide by the 3. So x equals negative 1/3. Okay? X equals negative 1/3. Any questions on the first example?
No.
You guys okay? Yeah. Stuff's making sense? How about you guys back there? So, back row? Yeah? Alright. Let's tackle the middle guy. The middle guy, again, you're going to see one that isn't in a fraction. So that number 3, we're going to put over 1. So you have to create a fraction. Is everybody okay if I wipe it away? Alright. Okay, same rules. Over 1. What is my common denominator in this case?
X squared.
X squared. We need the variable. So x squared, 1x squared. So something over x squared plus something over x squared equals something else over x squared. Okay. I need to times this guy by the x squared because he doesn't have one. So he's going to be 3x squared. What do I multiply by the middle guy?
1x.
Just 1x because he already has one. So just x. Just x. Hey, what about the guy on the right? Nothing. Good. He doesn't change. Now we get rid of our bottom. What's our non-permissible? 0. Good. So x cannot equal 0. All right. We notice that we've got an x and a digit, and we've got a squared. Because of that, we need to create a quadratic and then factor it. So the 4 is going to come over here. We're going to have 3x squared plus 1x minus 4 equals 0. And now we have to factor that guy. Now there's a couple different ways. Some people really like the quadratic formula. Quadratic formula is pretty handy to use, okay? Especially if you don't like factoring numbers where there's numbers in front of x. When there's numbers in front of x, 99% of the time they're going to factor it for you. But this was a question that turned into it. So you still have to be able to factor those. So if it turns into one like that, I would suggest using the quadratic formula unless you're really good at factoring. Okay? Does anyone like to use the quadratic formula, or is that your go-to, anybody in the room? No? Some people? No? You got a factor? Straight up diamond, man. Yep. Negative b plus or minus square root b squared minus 4ac divided by 2a.
I like to do that.
Factoring? Okay. So, we do the diamond. We've got a negative 12. I need a positive 1. What's going to be a positive 1? 4 and negative 3. Okay? The only difference when you've got a number in front of x squared is now because your brackets, normally your brackets would just start with x and x. Now it's going to start because we have to factor 3x and 1x. Okay? Instead of just x and x, we're going to have 3x and 1x. Because one of the numbers has a 3, we've got to divide the digit here that gets divided by 3 that will not give us a decimal. So we're going to divide the 3 because if we divide 4, we get a decimal. Okay? So this guy's going to give me a negative 1. His answer cannot go in the bracket he divided by. He divided by 3, so he's got to go way over here. Minus 1. This guy's answer, positive 4, will go in that bracket. Equals 0. Okay? Now what we got to do is we just got to take them out of brackets to find out what x is equal to. So what would x equal to in this case? Positive 1. It's the same as non-permissibles. So 1, what about this guy? 4 over 3. If there's a number in front of x, it's always going to create a fraction answer. Opposite side of this guy, so negative 4 over 3. So our answers are x equals negative 4 over 3 and positive 1. Now, the non-permissible with x can't be 0, so our solutions are possible. Okay? So remember, if you're dividing, or if you have a number in front of x squared that you're factoring, you have to divide the wings by them. The other guy divides by the 1. Okay? Alright, let's try the guy on the right beside him. He's almost identical. I want you guys to do it by yourself. This one right here with the 5 and the 6. It's almost identical to what we just did. You guys try that one. Okay? Try the one next. Right beside it. Okay, so most of us have our common denominator as x squared. So we would end up with 5x plus 6 equals 6x squared. Whenever we have an x squared, we need to move everything to the side that makes the x squared positive. The x squared is positive where it is. So that means everything else has to move to his side, because you always keep x squared positive. So now that changes the 5x to a minus 5x, and the 6 to a negative 6, because you have to change which side they're on. So now you're going to get 6x squared minus 5x minus 6 equals 0. At this point, now you're going to do a diamond that I've shown you on the whiteboard. So the diamond I've shown you is negative 36 and a negative 5. What you do is make a factor list of negative 36. How did I choose that the bigger number was negative? The guy on the bottom of the diamond decides. Whatever sign he is, the bigger number takes his sign. So if this guy was positive, the big number would be positive. Okay? So that's how we do that. We make a factor list of 36. That's how we came up with negative 9 and 4. But the kicker here is that we have a number in front of x squared. So we have to factor 6. We have two choices, 1 times 6 and 2 times 3. So the reason that we're going to choose the specific answer is because it's going to be the numbers that divide the wings. So it's going to be these guys. We have to divide them by either a 1 and a 6 or a 2 and a 3 without getting a decimal answer. The only one that works is 2 and 3. Everything divides by 1, but if you divide either of those by 6, you get a decimal. So this guy will divide by 3, this guy will divide by 2. So since I chose those two numbers, that pair of numbers, that means they have to start my brackets, like there. So I'm going to write that up here underneath. So I'm going to have 2x to start one bracket and 3x to start the other. Now the important part is, whatever number you divided on your ways, the answer is going to go in the other bracket. So this guy divided by the 3, his answer goes in the 2 bracket. So it's going to be a minus 3. This guy's answer goes in the other bracket, positive 2. So now we need to remove them or create them equal to 0, meaning find out what x is equal to for each bracket. Now remember, we always take the opposite sign of this number and then we create a fraction with the number in front of x. So this guy's going to give us negative 2 over 3. And this guy's going to give us positive 3 over 2. Yes? Was that your question?
No, I figured it out.
Oh, you did? Okay. So the actual answers for x are positive 3 over 2 and negative 2 over 3. Okay? And if you're not sure how that works, what you do is this. If you're not sure, please watch up here. You make each bracket equal to 0 and solve for x. I would go 3x plus 2 equals 0, and then literally solve for x. Move your 2 over, subtract 2. That's how we get our negative 2 on top. Then you got to divide out the 3. Oops, 3. Okay, that's how we get our negative 2 over 3. Okay? All right, this one I'll leave for you guys to practice. We're going to move down on to the binomial denominators. Okay? Down to the binomial denominators. All right. So, working with these binomial denominators, if the bottoms are completely different, you must use them all. So, for example, x plus 4 and x minus 2 are completely different, so I'm going to use both. So what you do is you multiply to the opposite side. So the 5 is missing x minus 2 on the top and bottom. X plus 4, x minus 2. Okay? Equals 3, and what's he missing? The x plus 4. Now I've written it this way on purpose, because I'd like to show you exactly what's being added. So, that side was missing the x minus 2. The right side was missing the x plus 4. So you're putting whatever each side is missing. That's what you're doing. You're converting your top. That's how you convert the numerators. The minute you've done that, and you identify non-permissibles, then you can solve for x and get rid of your denominator. So, non-permissibles, NPVs, x can equal what in this bracket? Positive 2. Other bracket, negative 4. So 2 and negative 4. All right, there's our NPVs. The minute we've done that, the bottom is now gone. Okay, it doesn't exist anymore. Now we're dealing with the top. We have to multiply into the bracket. So we're going to multiply in. 5x minus 10 equals 3x plus 12. Okay? So from there, we're going to move the x to the left. Minus 3x. Minus 3x. There's no x squareds anywhere. So we're taking the digits to one side, the constants, and the variables to the other side. So the negative 10 is going to become a positive 10 and hang out with the 12. That eliminates things on the wrong side. And now we add like terms. I'm going to get a 2x equals 22. And now we're going to divide out what's in front of x. Divide by 2. How big is x? 11. Good. So x equals 11. So we always check the non-permissibles. If any of my non-permissibles? No. If the answer was one of my non-permissibles, I would say no solution, because the answer is a non-permissible. Okay? And you have to be very specific about that. All right. These are extra examples for you guys to work through. I want to work through D with you, and then we've got a worked example on the next page. Or I should say lower on your page. But I'm going to do D with you. Okay? Everybody ready? Okay. So, letter D. There's one thing you've got to do. The minute you see an x squared, you need to see if you can factor something. So I have an x squared, it's a difference of squares. So immediately square root. And now you're going to start x plus 2 or 1, x minus 1. So now we look at both sides. The left side has 2 brackets on the bottom. The right side has 1 bracket on the bottom. Is one of the brackets the same?
Yeah.
Yes. So that means the guy on the right is missing that bracket right there. So we have to add that bracket to the right-hand side. Okay? Once we do, we can get rid of our bottom. Okay? So our common denominator is x plus 1 and x minus 1. So what can't our, what are our non-permissibles? What can't x be? Plus and minus 1. X cannot be plus and minus 1. All right, let's see how big he is. So, now we're going to get rid of our bottom. We don't need it anymore. We're just going to multiply this guy into the bracket. We're going to get a negative x squared on the right-hand side. We always want x squared positive. So that means we're going to move everything on the right to the left. We want x squared positive. So, 3x plus 1 equals negative 1x squared plus 1x. Again, be careful. You've got a negative times by a negative. That's going to give you this positive here. Many kids miss that. Be careful there. All right, so those guys are going to go to the right. So they're going to go opposite side. So positive 1x squared, positive 1x squared, minus 1x, minus 1x. Now we're going to add the x's together on the other side. So we're going to get x squared plus a 2x plus 1 equals 0. This is another one where we straight up diamond factor it. What multiplies to give us a 1?
1.
1 and 1. Does 1 and 1 give us a 2 when we add them?
Yeah.
Yes. So that means our brackets are x plus 1 and x plus 1 equals 0. You might also see it written like this, x plus 1 squared equals 0. They mean the same thing. So if I take that answer out of brackets, what do I get?
Negative 1.
X would be negative 1. But is he allowed to be?
No.
No. So that's why I did this question with you. This is a no solution question. So we would say, so we're going to suck her up. X equals negative 1, but no solution. And if you want to write your reason, it's B/C because the answer is a or an NPV, non-permissible value. It is a NPV. Okay, it is not allowed. That is the reason. Okay. On the bottom of your page, you're going to see another one. And this one's kind of a big one. This one requires a lot of factoring. So I've got all the steps worked out. We're just going to walk through each step. Okay. So what happened during this first step? Everybody look. What happened during this first step? What did we do? What do you notice right away, first of all? They factored the bottom. If you see brackets all of a sudden, that means they factored something. So we have brackets all of a sudden, so what they do, they factored the denominator. Okay? What they do in step 2? What are they noticing? What are they pointing to? They The NPV, non-permissible value. That's what we found there. All right. What was done during this step right here? Now they're showing it to you longhand. Same way I showed that other question to you. I'm just going to jump back to it for a moment. This last question, where was it? Okay, where I highlighted down here, where I highlighted the part you had to add to both sides, the part that was missing, that's what they've done here. They've highlighted, okay, what was the 2 missing? Well, he had the z plus minus 1, z plus 2, but what does he need? The 6. But you have to include everything. How come? Because those will wipe off, and they do that on purpose. So what stays at the top, the 2 will multiply, or the 6 will multiply it. Okay? That's what they're showing. Okay? So what have they done? They've done common denominator converts. What that means is convert the numerators. So this is when we change all those top numbers. Okay? What did they do in step 4? What do you notice is gone in step 4? What did they remove?
Denominator.
The bottom. So they cleared, it's called clearing fractions. They cleared fractions. You could also say canceled the denominator. Okay, you cancel the denominator out. You cleared fractions. They solved for z after they cleared the fractions. They solved for the answer. What are they doing here in this step? There's no longer a variable. They get a digit equaling a digit. What is going on in this step? What are you noticing? Look very carefully. They're substituting the answer they have. So this is the check. This is the left side equals right side check. They're plugging in the number, they're substituting the value in for x. Okay, they're just substituting it in. Any questions there? The reason I gave you a big, long worked example was to show you how each step works. The next one, this is also a worked example on purpose. All right. We take a look at this guy. We've got x plus 2 on the bottom, x minus 2 on the bottom, and then we factored that guy. And we ended up with both x plus 2 and x minus 2. So at this point, we need to now multiply to the other side what everybody's missing. So this guy has 2 brackets. Each of the other guys only has 1. So you have to put the bracket that they have different. So this guy's going to get the x minus 2. This guy's getting the x plus 2. But when you do it to the bottom, you're doing it to the top. So that's why, besides the 3, they have the x minus 2. Now, would we write it that way? No. We would write the 3 as the coefficient. We would do it this way so we could multiply it in. They're just showing it to you this way is all. Okay, they mean the same thing. This one, same thing, you'd multiply the 5 in. So we would write it 5 bracket x plus 2. Okay, that's how we would write it. It doesn't matter, they mean the exact same thing. They're gathering like terms, they solved for x. This one says do a left side, right side check. Make sure each side equals 0.025. Okay? How do we know it's going to be equal to that? We need to store x in the calculator. So what I'm going to do is I'm going to store x as -9. So everybody grab your calculator. The store button is above the on button. So I want to store x as -9. I need to type my number first. So -9, then I hit store, then I hit x, then I hit enter. Now I type in the left side of my equation. So I need to type in this part right here and see what it equals as a decimal. Then I'm going to type in that part and see what it equals as a decimal. So in this one, I'm going to type in 3 divided by, I need to open a bracket, x plus 2, close my bracket. Okay, I need to get my answer for that. And now I'm going to go subtract big bracket, so open a bracket because I have to subtract this part. 5 over x minus 2, so we're going to have some double brackets. So what it's actually going to look like, I have to minus 5, divide by, open another bracket, x minus 2, close, double close. Okay, that's going to give me 0.025, which is what they showed me here. Okay, left-hand side, I got that for an answer. Now I need to check the right-hand side, so I'm going to type the right-hand side in. So I'm going to go 2 divide by, open bracket, x squared minus 4, close my bracket, enter. I got the same answer. So my left side equals my right side, I know my answer works. Okay, so that's doing the check. The way for on the very next page, or on the bottom of that page, that's the showing how to do the check in your calculator. Okay, this is how to store answers to do the check. All right, we have one last example to get through, example 4. We have one thing to factor. We have an x squared, so we're going to not diamond it, we're going to difference of squares. So square root. So we're going to get x plus 3 and x minus 3 on the bottom. So just instantly looking, the bottom on the left has 2 brackets. The guy on the right only has 1 bracket on the bottom. So that means I need 2 brackets on my bottom. So I'm going to have to put another bracket to the right-hand side. So which bracket do I have to put on the other side? The plus 3. Good, the one that's missing. So I'm going to multiply the top and the bottom, the x plus 3. Okay? Now we can get rid of our denominator. So what are the non-permissible values for these? Plus and minus 3. So x cannot be plus and minus 3. All right, since the left-hand side had both bottoms, we didn't have to change the top. So now our bottom is gone.
Can't it also be 0?
All we have now is 7x minus 15 equals, I've got to FOIL this. So we have to FOIL it or area box it. So I'm just going to do a quick area box right here. So we're going to have x and a negative 2, x and a positive 3. X squared, negative 2x, 3x, negative 6. There's our like terms. So it's going to equal x squared plus 1x minus 6. Because I have an x squared, we need to move everything to the side where x squared is positive. So that means this red stuff has to move to the right. But when you move it there, you have to do the opposite sign. The 7x is coming over as a negative 7x. The 15 is coming over as a positive 15. So minus 7x plus 15. Minus 7x plus 15. Okay? So now we end up with x squared. We've got to add our x's and add our digits. Minus 6x plus 9 equals 0. Now, if we factor that, we're going to get x minus 3 and x minus 3 equals 0. The only answer I can get out of those brackets is positive 3. It's the only possible answer. But is that solution possible? No. So we say no solution. We say no solution because this answer is one of our non-permissibles. It's an answer it's not allowed to be. So that means we have no solution. Okay? This concludes lesson 2.5 on solving rational equations. Bye-bye.